Normally, the crown wheel has teeth made of metal, or as in most wooden clocks, the teeth are replaced with metal pins. But I thought, wooden clock, wooden teeth, and thanks to high-grade aviation plywood, it worked out better than I had hoped. Clamp a piece of arbor in a vise or in a hole in a block of wood, and add a ring stop. Make sure you have all your clamps to hand. Now, apply a bead of glue to one of the teeth strips. Pay particular attention to the ends and don't be too sparse. Also, double check that you are gluing the right side. Note the position I am starting. This ensures that the strip end is not behind a spoke, which will make clamping difficult. The ends need the most pressure, so you will have to use strong spring clamps. To get the maximum pressure on the ends, place the clamp as shown. You can use smaller clamps for the middle part, as the force required is a lot less. Just make sure the back of the strip is flush with the back of the crown wheel. Before the glue is thoroughly set, remove the clamps and with a sharp knife scrape off the surplus. As to when you can do this, that greatly depends upon glue used and the ambient temperature, but normally it would be after about 20 minutes. Before you glue on the second strip, do a dry run to check that the strip fits. Although I built the crown wheel several times to test, and each time worked without any problems, if there is one thing I've learned in my short life, it's never to say never. Use a putty made of glue and sanding dust to cover up the butt joints. Put the thinned main arbor in the upper bell arbor position and tighten the frame coupling. Use 2 ring stops to hold the crown wheel tightly. It is important to make sure you have no back to front movement. I use double-sided sticky tape to stick some 120 grade sandpaper to a wood block. Now with the block just touching the teeth, slowly turn the crown wheel. Admittedly, it sounds pretty brutal, but if you are meticulous in the building process, you will be only removing a millimeter or 2. Advance the block slightly and continue the process until you get an even scraping sound. As mentioned in the instructions, it is the teeth tips that need to be in line. The slight wobble on the crown wheel is unimportant. Now we will take a look at the Verge and folio. Both terms come from the French. Verge just means stick or rod, but interestingly was also used in Old English as a euphemism for the male member, so be careful about the context you use it in. Here you can see the repelling magnets at work. It is important that the Verge and folio swing with as little friction as possible. By moving the upper magnet, you can center the Verge opening with the main arbor. As the supplied weight has saw marks on its surface, if you wish to keep the weight visible, I would strongly recommend polishing it. Here I am using a dedicated disc sander, but a drill attachment will do the job just as well. As with all polishing processes, you work from rough to smooth. As the weight is brass, you can use a normal wood abrasive disc. I used 120 grade for the rough smoothing. To get an even bevel, make a groove at 45 degrees to the disc. Very gently push the weight against the disc. You will find that the downwards travel of the disc will almost turn the weight by itself. Take your time and make sure you have an even bevel. Now I have moved up to a 400 grade. I then applied some polishing compound to the disc to make the 400 grade even finer. To do the polishing, I have just stuck a piece of felt to a sanding disc. The belt supplied is cast bronze, and as you can see on the left has the typical dimpled surface of a casting. I find it attractive as is, but you can of course also polish it. Polishing, however, has no influence upon the tone of the bell. Tighten the bell on a bolt or threaded rod. Using 100 grade, smooth out all casting dimples. So okay, that was a bit boring, but with your permission I would like to bore you a bit more and show you how some of the Octavus parts should turn in order for you to have a working timer.